In Chicago, there's no room to grow, but an underground city could house thousands. This is mega engineering.
Welcome. Please enter your floor. Minus 78. Going down. This is a Chicago Underground City Express elevator with direct connections to all residences, shops, and offices below level 50.
Chicago, Illinois, the nation's third most populous city, an iconic skyline, and an urban grid teeming with the daily rhythms of city life. But Chicago is a victim of its own success. 2.8 million people call it home, which means this great metropolis is under a daily assault. Almost 7 million commuters move in and out of the city every weekday. Even the suburbs, once an antidote to the chaos of city life, are clogged with traffic.
Despite the improvements in the interstate highway system, the traffic is still growing. In fact, there is, as in all major cities, there's an hour delay at rush hour.
When it comes to traffic, the second city is second only to New York, costing Chicagoland residents nearly 1 week per year of lost time, and the local economy over $4 billion annually. When suburbanites finally make it downtown, they find the L, one of the nation's oldest, busiest transit systems, bursting at the seams. Unable to expand to accommodate a growing ridership and an ever-widening definition of rush hour.
Well, the subway and L stations are only built for 8 cars, so therefore to increase the capacity in the system, it would be necessary to increase the size of the stations, and that would come at a very great expense.
Undeveloped land around the city is scarce, so growing out is no longer an option. And with downtown real estate at a premium, the city needs a drastic, some say groundbreaking, solution. Chicago, already home to some of the nation's tallest buildings, will have to build down. Imagine an underground city directly below the Loop, over 1,300 feet deep, containing nearly 100 floors of apartments, offices, parks, and more. Room enough for tens of thousands of people to live, work, and play. It's the best solution to the Windy City space crunch.
Quite clearly, you can get more people doing something or living or whatever you want to do in this underground space, where now you have very limited space on top.
It's an undertaking so big, so innovative, that it will usher in a public works project of unparalleled dimensions, challenges, and dangers. It will require excavating over 230 million cubic yards of rock, construction crews laboring tirelessly below millions of Chicagoans, to build living spaces with new methods of ventilation and lighting, to ensure that the city beneath Chicago succeeds. It won't be easy, but it may be necessary. Expanding underground is a solution that's becoming more plausible, with the emergence of new techniques to make living underground a reality.
All this is technologically doable. It comes then very quickly down to what is the other side of engineering, is what does this cost and how long does it take to build.
Chicago is an ideal place for this bold experiment. From the ashes of the Great Fire of 1871, the city grew to become the epicenter of an architectural revolution, spawning the first skyscraper in 1885 and hosting the most influential World's Fair in history in 1893. By building underground, Chicago will cement its reputation as one of the most forward-thinking cities on the planet. But it may not be the first. Amsterdam is already proposing to make space below ground where none exists above. In this Dutch city, where streetcars, pedestrians, and 550,000 bicycles compete for space along narrow streets, the volume of cars is a growing problem.
Because Amsterdam is a nice historical town and there is a lot of traffic in the town, you cannot enjoy the town because everywhere there's traffic on the channels, there's traffic on the quays, everywhere there's traffic.
Ancient city planners never foresaw a day when their picturesque byways would be overrun with automobiles. Today, there's a movement to get them off the streets. But to do that, while still maintaining Amsterdam's historic charm, it has to look towards a signature feature of its historic past: the city's canals. Amsterdam is already proposing to make space below ground where none exists above. The plan? A network of underground complexes built beneath the city's 65 miles of iconic waterways.
So we thought we bring a lot of functions who doesn't need daylight under the ground.
Parking garages, movie theaters, and shops, all built beneath miles of real estate that just happens to be filled with water.
Working in the canal space is indeed the best option, because you make from 1 square meter which has no value, you make 6 square meters which has a lot of value, of course.
In fact, the plan will convert over 20 square miles of largely untapped space and provide storage for thousands of cars. But building in Amsterdam requires sensitivity to the city's unique architecture. Amsterdam's streets can't be choked with construction equipment. Some are so narrow that the massive trucks needed to build underground won't even fit.
We don't want to have any trucks in the town because that gives an awful lot of mess, and we don't want to mess up this nice historical town.
Even if crews could access the area from sidewalks, they'd be dangerously close to the city's narrow canal houses, precariously perched above the waterways.
Let's say in Chicago, you have to drill a hole and you can place a house. It's a complete other way of building. In Amsterdam, it's not so easy to build a house because of the soil is what some call soft water.
Amsterdam's soft water, or swampy soil, makes constructing large, heavy structures nearly impossible, which is why buildings are rarely higher than 3 or 4 stories. Most of the canal houses are supported by little more than wooden piles extending into that soft water. Heavy vibration generated by construction could spell disaster. Only the canals are far enough away from buildings and wide enough to fit construction equipment. But the canals are filled with water, so engineers have proposed a solution as unique as the city itself. Amsterdam's canal system has 16 working locks, which can be closed at any time. With the locks closed, the canals can be drained.
I can imagine that people think that the most difficult thing is to bring out the water out of the canals. But in fact, that is technical one of the easiest things.
Once the canals are dry, crews will get to work, digging 30 feet down before sealing off a new surface that's both sealing to the complex below and floor to the canal above. It's a solution that will not only minimize the risk to the thousands of buildings that abut the canals, but will also keep the city from having to shut down.
Because we are working in the canal space, there is less inconvenience for the people.
Later, restoring the canals is as simple as opening the locks.
After we have finished it, the canal is exactly the same as it is now. Only there are no cars on the ground anymore, so you can enjoy the city and the nice historical houses.
The project would remove thousands of cars from sidewalks, and if it works, it could spur other cities to take up the challenge. There's just one problem. Few cities have canals from which to access their downtowns. In Chicago, there's simply no way to dig up streets without paralyzing the city and infuriating millions.
People are afraid of change. That's difficult. It's not a technical difficult, but it's very difficult to explain them. You get a better city.
Chicago may be the perfect location for this subterranean experiment, because deep beneath the glass, steel, and asphalt of this historic city lies an even richer geological past.
Well, I think it's easiest to think of Chicago geology as being a layer cake of widely differing geologic materials.
The first layer is approximately 100 feet of glacial clay, loose, soft material that's barely suitable for large structures. But beneath that lies 400 feet of limestone, strong rock that's perfect for hollowing out large chambers.
The limestone beneath Chicago is advantageous because it is stronger than concrete, typical concrete that we pour for structures.
That layer is followed by over 100 feet of shale, an unstable rock that's less ideal for building.
Shale is 5 to 10 times weaker than limestone. It is subject to this phenomenon that we call slaking. When exposed to water, it expands and fractures and degrades.
Vertical access shafts could be drilled through the shale to the next layer of limestone, which extends for another 400 feet. It's a pattern that repeats again down to 1,300 feet before hitting a deep layer of sandstone.
The top of that sandstone is weak, very weak. So weak, in fact, that it can be mined with a fire hose.
That weakness means that the underground city could go no deeper. But it's the alternating sections of limestone that make Chicago an ideal location for this feat of geological engineering. And excavating limestone is something with which Chicago is already familiar. Here at the Vulcan Mine in Naperville, Illinois, 45 minutes from downtown Chicago, an active limestone and dolomite mine has been in operation for more than 2 years, with enough material left for decades more.